Good afternoon. We are here to present the PBL. We are the team number 1 and our team are composed by Monse, Cuauhtémoc, Ricardo, Rafael and me, Cristian.
For this period, we have to find the distance that the racers actually traveled during the race. The race took place in 1992, monitored by a GPS with a great exactitude. However, the NASA provided us with the speed of the racer from the beginning to the end. Also, they include an Excel with a graph and a list of values of time and velocity.
Before we start with the PBL, we need to list the things that we know and the other things that we don't know. Three of the things that we know are an Excel document in which has the given points and a graph with the velocity versus time. And we know we must find the area under the curve. And some of the things that we don't know are how to use the data of the Excel document and the formula of Simpson or other methods to calculate it. The complete list is in the document.
This is the Excel with the values, this is the graph, and these are the values that they gave us. For the Simpson method, to get the result of this, we used a formula. The formula is here in the document of the PBL. The formula says that we have to take a value of the list and multiply it by 4 times 4 and then add it the other value, multiply it times 2 and then the other value, multiply it times 4, and this is a sequence times 4 times 2 times 4 times 2. Then we do the sum of all these values and multiply it by delta x. The value of delta x is b minus a over n. N is the total number of values that we have. In this case, the total values that we have is 181. Here is the value, 181. The letter B is for the column of time, and the letter A is for the column of velocity. This is the column of velocity, and the column B is the column for time. So we do 90 minus 0 over 181, and all that is delta x. Then we do that value divided by 3, and the result that we have is 90 over 543, and then we do this fraction multiplied by the sum of the values multiplied times 2 or times 4 or times 2 or times 4. When we do the sum of these values, we have the approximate value for the area of the graph, that is 1196.43, and this is our approximate value for the area that is under this curve.
We can conclude that this project helped us to apply our knowledge acquired during the course. We also showed that we can solve any integral by using any method. In this case, we use Simpson's rule to obtain the area under the curve. Although we didn't know about this topic, we made a research on the internet and on the Stewart's book to find the formulas so we can solve this problem. This is a different kind of integral because it's solved without a given function.
For the application of these things, we could apply it in physics, in math, on any area that is about calculus, But if you want to see an example in the real life, we could do this with a form. If we want to build something that isn't with a regular form, we have to use this kind of integral to calculate the area under the curve. For example, a NOVA tunnel with a round bottom. If we want to fill it with water, we have to do this kind of integrals. And this is one example of the applications that we could use this thing. Thank you.
Thank you.
Thank you.
Thank you.
Thank you.